Biological molecules, lipids. There are three different classes of lipids. This is the only group of biological molecules that do not consist of monomers that are linked together, and they have three unique structures. We have the fats, phospholipids, and steroids. If we look at fats, fats consist of a glycerol molecule. Glycerol is a 3-carbon molecule, shown here with this atomic structure. Here is the actual structure of it just as it's drawn out. Remember, each of these little bends here represents a carbon. And then consists of fatty acid chain. So here would be a fatty acid chain, a long carbon-hydrogen chain, and it's attached to a carboxyl group. Here it's shown in terms of the atoms, and finally here is actually the actual molecule, what it would look like if it was put together. So how do these molecules come together? Monounsaturated fats only would have one double bond within them, and so this causes them to actually bend. Here's your carboxyl group, but you see this bend in the molecule. And then your polyunsaturated fats have 2 or more double bonds in the carbon chain, so they tend to be even more bent. Here again is the carboxyl group that is going to form that bond in the glycerol molecule. So how do these molecules come together? The fat molecule is called a triglyceride. It consists of the glycerol joined to 3 long carbon organic acids called fatty acids. So here's your glycerol, and here are those fatty acids. When this bond is formed, it is due to due to an ester bond, and it is formed by dehydration synthesis. So this ester bond forms between the hydroxyl group on the glycerol and the carboxyl group on the fatty acid chain, and in the process a water molecule comes off because of the OH over here and the HOH over here. And you can see 3 of these would be formed. Here you can see the actual triglyceride once it is formed, and this is known as the ester bond. It's formed by dehydration synthesis, and in this diagram you can tell that all of the fatty acids are saturated. And the reason? There are no double bonds. If we summarize the different types of fats, we have our saturated fats, such as our butter. The carbon chains are all straight, molecular packing is very dense, high melting point, they are solid at room temperature. If we look at our unsaturated fats, we have our oils. They have the chains is bent because of some double bonds. They're much less dense, and therefore they are liquid at room temperature. And then finally we have some unsaturated fats that are trans fats, and these are when we have got still have some double bonds, but they still are more dense and have high melting points, so they are solid again at room temperature. The second group of lipids are your phospholipids. Phospholipids make up our membrane. These phospholipids consist of a glycerol portion attached to 2 fatty acids. You can see again that these fatty acids have got this one has got a double bond in it, so therefore it is kinked. And then it has on the 3rd carbon of the glycerol, we have this phosphate group that is attached, and then also a choline over here. This gives it the phospholipid head of our phospholipid membrane that forms the membrane, and this portion is hydrophilic, likes water. This portion is hydrophobic, and these phospholipids assemble into this bilayer membrane that you will learn all about. The final kind of lipid are our steroid lipids, and steroids, the most important one is your cholesterol. Cholesterol is the molecule that is an important makeup within our membranes. We look at cholesterol, it's actually a ring structure with a carbon chain of this 5-ring carbon at the end. I want you to notice that steroids, cholesterol is very similar to 2 important steroids you might know of, testosterone and estrogen. You can see this ring structure is exactly the same, and the only difference is when you look at these side chains. Testosterone has got a hydroxyl group on both sides, and then the difference between testosterone and estrogen are your methyl group and a hydroxyl group over here and a carbonyl group over here. These small differences have huge biological effects.